Hello everyone. So today we are going to continue our basic mathematics series where we are going to look at some important basic mathematic formulas and tricks which will help us in our future programs. All right. So today we are going to learn about factorial of a number. Right. So before jumping to coding, let's talk about what is a factorial. So if I say factorial of n, it is represented by this n with an exclamation mark. So this is equal to n, all right, into n minus 1 all the way to 1. All right. Hence, n factorial means multiplication of numbers from n till 1. All right, like n into n minus 1 into n minus 2 till 1. All right. For more understanding, let us see these examples. So, suppose our input is 4. So, what would be the factorial of 4? 4 into 3 into 2 into 1, which is going to be what? 4 into 3, 12 into 2, 24 into 1, 24. Alright, hence our output is 24. Now, suppose if our input is 6, so it is going to be what? 6 into 5 into 4 into 3 into 2 into 1. So what this value is going to be? 6 into 5, 30, 30 into 4, 120, 120 into 3, 360 into 2, 720. Alright, hence output is going to be 720. Now, how are you going to code this? So it is very easy coding part where you'll use, um, a loop where where you'll have an integer where you'll multiply n, and in every pass you are going to decrease n, and this loop will run until n becomes um, equals to 1. Alright, so this is what the coding part would be. So let's try it. First, let's include header file, then using name space std. Let's have a main function. Let's have n, which will be a user provided number. And what we are going to do is we are going to use a function called fact. So what this fact is going to do is it's going to have input as a parameter, and it is going to return the value of the factorial of that number n. So for that, let's have a variable which will store the factorial value. And now let's have a loop which is going to be I, which is initially going to be equal to 2, and we'll run this loop till I becomes equal to n, and we'll increase it at every increment. All right, and now res is going to be what? Res into I, right? So what res would look like? 1 into 2 into 3 into 4 until I becomes n. So this loop will run till I becomes n. Alright. And then we'll just simply return our value of s. So let's try and run this program. Okay, let's take the example values. Let's have input as 4. Its output is 24. The factorial of 4 is 24 as we saw it before. Alright. Now let's have 6. 720. Hence the code is working. Alright. So I hope this was clear to you. What is factorial and how to find it through programming. Now let's talk about trailing zeros in a program. Alright. Now let's have input as 6. Okay, what is output? 720. All right, and if we have input as 10, then what would be the output? What would be the factorial of 10? So it is going to be 3628800. All right. So if I ask you what would be the number, what is the number of trailing zeros? Trailing zeros means right to left consecutive zeros. Suppose here it is 1, and if our input is 10, the number of trailing zeros are what? 2. All right. Now our task is to find the number of trailing zeros and write a function about it. Alright, now you may pause the video for 2 minutes and think about the solution, brainstorm for a while, and then come back to this video for the solution. Alright, now what is the factorial of a number? It looks like this. If I ask about factorial of, this would look like this: 1 into 2 into 3 into until n. Alright, now if I ask you like how many zeros would be there in this list, so I'll simply say that if we find the number of 2's and 5's as a pair in a number, they will result into number of trailing zeros. Yes, because 2 into 5 becomes 10, and any number multiplied by 10 results in a trailing zero. Suppose if a number is 72, and if we multiply it by 10, number is going to be what? 720, right? Suppose your input is 6, so what would be the factorial? 1 into 2 into 3 into 4 into 5 into 6, right? How many number of 5s and 2s are here? 1 5 and 1 2. There would be like 2's here also. Yes, 2 into 2, and 2's here also, 2 into 3. But if you have to find the number of pairs of 2 and 5, so it is going to be 1, because there is only 1 5. Alright, so this is clear to you. And there's also one more interesting fact here, that in a factorial, number of 2's would always be greater than number of 5's. You can clearly see that even in the factorial of 6, small number, we have only one 5 and the number of 2s are 1, 2, 3, 4. So at any point, the number of 2s are going to be more than or equal to number of 5s. So hence the task is reduced to find the number of 5s in this whole trail of numbers. Alright. Now you can see that after every 5 turns, we are getting a 5. Like here is a 5. Then somewhere here we will be having 10. So there is a 5. Then at some point we are going to have 15 where we'll find a 5. So we can say that in a factorial, number of 5s are going to be what? N by 5. Okay, these are going to be minimum number of, at least there would be these number of 5s at least. So now I might be wondering why I'm saying at least. See, there is one more number, 25. It is going to have how many number of 5s? 2, right? But since we're dividing n by 5, we'll only get 1. And there's also going to be a number 125 here somewhere. So how many 5s are going to be here? 3, but we are only counting 1. So effectively I can say that number of factorials are going to be n by 5 plus n by 25 plus n by 125, and this list goes on, right? So now you might be wondering that how can we stop this this infinite trail, right? So if n is less than 5 par k, we'll stop after k minus 1 passes. Suppose our n here is 27, right? So we'll find this one, n by 5, n by 25, and then but we don't have to compute this because this is going to be 0, right? And the future values are also going to be 0. Suppose n is 127. So we'll find n by 5, we'll find n by 25, we'll find n by 125, but we won't find the other numbers, right? Because there's no point because it is going to be 0, right? So this is how we are going to find the factorial, trailing zeros in a factorial. Alright, now let's try to code this thing. Okay. Let's have a header file here, first of all. Let's have, using namespace std, let's have our main function. Let's have n as user defined number, and then we'll see out trail of n. So we'll have a function of trail which is going to have input as a parameter, and what we are going to do is we are going to have a variable int res which is going to be equal to 0. Now we'll run a loop. We'll initialize iterator as 5. We'll run it until I is less than or equal to n. And now what we'll do is we are going to initialize I as I into 5 because we saw that n by 5 plus n by 25. Hence we have to increase I by a multiple of 5 every time. Now what we are going to do is we are simply gonna add n by I to res. Alright, now if I go back to Blackboard, what did I tell you? Res is going to be what? Res n by I. So initially res is what? 0. Hence what I can say here is that this thing in the loop represents this, because initially I is 5, then it will become I by 25, then it will become I will become 125, and so on. And as soon as I becomes more than n, then it will break, right? So this was it, and now what we'll do is we'll simply return res, right? Now let's no wait a minute. Yes. Now let's try to run this function. So we had 6 as a example input. Let's have it. Number of trailing zeros are 1, right? See, number of trailing zeros are 1. Now let's have another example input 10. Number of trailing zeros are 2. Yes, you can say number of trailing zeros are 2, right? So yeah, these are the two programs which I wanted to tell you in this lecture, and I hope you got what is factorial, how to find it, and how to find trailing zeros in a factorial. So yeah, that's it for this lecture.